Welcome to the final installment of the water supply update. Captain Vita here once again, and we're going to wrap up with relay pumping. We'll be going over what relay pumping is. We'll go over relay pumping operations, and we will wrap up with the evolution that was conducted with the new recruits, training division, and Groveland Fire Department, just to show the overall deployment of the operation. What is relay pumping? Relay pumping defined: supplying water from a supply source to a destination through hose utilizing multiple pumps, engine companies, to maintain a constant pressure and GPM requirement or need. We're extending the water main using our hose and keeping the pressures maintained. Got a short little video here that'll show the concept of the relay pumping operation, and we'll continue on. We have a pumper at the water source. It lays line. The relay pumper is receiving water and keeping pressures where they need to be to supply the attack engine. Pretty straightforward. We'll go over relay pumping operations. This will follow what is in the S&P update, and we'll just go over them here in the lecture portion. The need for relay pumping is determined by the amount of water required and distance to a water source. Pretty straightforward. All Lake County Fire Rescue pumpers carry 1,100 feet of 5-inch LDH, with the red section making up the last 100 feet. Is to know that you're out of hose. For every 1,000 feet of 5-inch supply line that has been laid, an engine will relay tandem pump the line with an engine pumping at the hydrant. When laying the line, speed should be kept to 5 to 10 miles per hour on the hydrant side of the road. This permits for a neat lay, and when dressed to the side of the road, it enables additional units to get closer to the scene. The reverse lay will be the primary LDH lay used by the Department for relay pumping operations unless circumstances dictate differently. The reason for the reverse lay, the engine will end up at the hydrant every time. However, no two fires are alike, so the incident commander or water supply officer will make the determination on how we're going to do this operation. Once set up, the first engine at the hydrant needs to keep a minimum of 20 psi residual, and each engine that is pumping water through their discharge to the next engine needs to maintain a maximum discharge pressure between 80 to 100 psi. This is so the intake pressure relief valve of the receiving engine does not activate. We may hook into a hydrant that has an intake of, say, 60 pounds. By the time we supply 1,000 feet to the first pumper, that pumper is supplying another 1,000 feet to the attack pumper. That intake on the first pumper is going to drop. So we just need to make sure we don't go below 20 psi. And this picture gives a description on a relay pumping operation. The first engine here on the lower left is hooked into the hydrant, onto the pump panel or the driver's side. Through the large diameter discharge, they are pumping 1,000 feet of LDH to the relay pumper. It's going into the intake of the relay pumper, out of the pump through the large diameter discharge to the attack pumper. We conducted training with the new recruits, the training division, and had some assistance from Groveland Fire Department Engine 96. We conducted a full relay pumping evolution out in the industrial area of the county to show the actual deployment. So this will be a short video, and I'll just do a little narration to go over what's happening. So Engine 96 is going to be the attack pumper, and they're on scene and they're getting ready to flow water. Now, one thing to take into mind, that relay pumping operation can take some time and is labor intensive, but this is going to be for an extended duration scene, or we need to get volume of water to a scene. So they pulled off their LDH line and they brought it over to the pump panel. left it there for 9.6 to hook into. And they're going to drive towards the water source. Meanwhile, engine 9.6 is flowing water. For training purposes, we were keeping at a low GPM because we had a 2,000-foot relay operation. We've identified that the hydrant is going to be on the north side of the road as the viewer is watching. So engine 70 is laying the line 5 to 10 miles an hour, keeping it nice and neat and off to the side. That way, additional apparatus, or if we have to reposition apparatus, is given the opportunity for open road. During this evolution, we couldn't do a straight 2,000-foot run because of the dynamics of the area we were in. So we actually laid 1,000 feet, made a turn after laying 1,000 feet and continued on another 1,000 feet. You see the hose bed is getting emptier on engine 70. And they were at 1,000 feet of LDH in this truck. So for training purposes, so the last section is actually the 1,000-foot section. It would normally be 1,100 on in-service units. So they make the turn. Engine 83 estimated where they're going to be stopping at. It was a pretty good estimation, within a couple feet actually. Crews get out of the apparatus and pull the additional LDH line off the truck, and they're going to hook it up to the discharge of engine 70 because they're going to be pumping water to engine 9.6. This is where they take some adjustment to get where they need to be. As engine 83 is preparing the hose to get off the truck. So that's leg one, engine 9.6 flowing water. Engine 70 drops off their LDH and drives towards the water source. Leg two is going to be engine 83. Engine 83 positions, gets on the side of the road, same as the hydrant. And they're taking 83's LDH and hooking into the intake of engine 70. Pretty straightforward operation. One thing to keep in mind, we have a lot of hands on deck with the recruits in here. But as engine 83 needs to proceed to the water supply, the line needs to be footed. We have it hooked up to the engine, but we got 3 personnel on the line drawing up tension so the hose will deploy out of the hose bed. For a little while here, you'll just see engine 83 deploying some hose. Nothing too exciting here, but I am going to stop here in a moment and explain a little bit of circumstances we got going on here. Now, because we're doing this in an industrial park, we did have hydrants every 300 feet, but we wanted to space out our 2,000-foot relay operation so we can show this video. And on that note, in high dollar value areas such as industrial parks or manufacturing, you'll typically see hydrants every 300 feet. Normal residential setting per our land development regulations is 500 feet. So the purpose of this training is we're catching the hydrant at the end of the line and we got to go 2,000 feet beyond it. We just didn't have as many hydrants as we needed. So you see 83 stops here. This is the hydrant we're going to be using for the drill. I'm going to show you how they're going to continue on. They're going to continue on with deploying the hose out of the bed of the truck. And you notice as there's less hose in the truck, The hose doesn't have that bite, so it's kind of just falling to the ground because there's not enough weight pulling it back to the truck. So this last section especially. So at this point, engine 83 deployed its 1,100 feet of hose. If it had to continue on to another source, we could use engine 83 and engine 70 as relay pumpers. 83 would back up to the 1,000-foot mark, hook the supply line to their discharge, and the next truck in line would hook to their intake and drive to the water source. But we only used 3 pumpers for this evolution, so to show the theory. And finally, here's a aerial overview of the operation to give perspective of how far we can go beyond the hydrant. And the drone footage is courtesy of Chief Smith with Groveland Fire Department. The hose is dressed to one side of the road. You can see that, it does curl a little bit. However, for the most part, it's off to the side. Apparatus can still get in and out of the scene. During this evolution, from the hydrant into the intake of 83 through 70 and everything like that, we were able pretty much to idle the trucks and flow about 1,000 gallons a minute out of their deck gun at idle. We threw more nozzles on at one point to see what we would get going to 20 PSI residual. We were flowing somewhere between 1,500 and 1,600 GPM before the hydrant got down to about 20 pounds. And engine 83 is back on the other side of that wooded area, 2,000 feet away, and we're flowing high volumes of water in an industrial setting. This can be done in any setting with an adequate water supply. You can set up a draft and do the same thing. You can hit a boat ramp and relay pump from there. You'll get truck capacity. As always, if you have any questions, feel free to send me an email or contact me at 742-3907. Thank you.